And the last type we're going to look at are cube roots. So we're not going to change anything. We're still going to do the factor tree. So we're going to do the factor tree for 54. So that's 2 and 27. That's 3 and 9. And that's 3 and 3. So I'm going to rewrite it as the cube root of 2 times 3 times 3 times 3. But now because there are triples, or we're doing cube root, we're looking for triples. So there are 3 3's. So the cube root of 3 to the third is just the whole number 3. So when I bring that out, whole number 3 on the outside, and then it's times the cube root of 2 underneath. And that's the answer to example 1. Now we're going to go ahead and just skip right to number 4. And again, we're going to break this up, first of all, into the cube root of 25 c to the 7th d to the 3rd all over the cube root of 64. Now, we're going to rewrite this. So this is the cube root of 25 is 5 times 5, and then we have c times 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 d times d times d. And then on the bottom we have the cube root of, and if we do the factor tree for 64, we have 8 and 8, 4 and 2, 4 and 2, 2 and 2, and 2 and 2. So we have 2 times 2 times 2 times 2 times 2 times 2 times 2. Oops, not too many there. So now, again, we will look for triples. So there's a triple, there's a triple, and there's a triple. So remember, only one factor from each of those sets comes to the outside. So that'd be c squared d, and then step left underneath the radical would be 25c all over. Here's a pair, and here's a pair. So then 2 times 2 on the outside would be the whole number 4, and there's your final answer. So again, when you're doing cube roots, you're going to do the factor tree, and you're going to write out the variables raised to the power, and you're going to look for triples. Now, if it was to the 4th root, we'd look for groups of 4. So